All right, we're going to begin Chapter 5 with a lesson called Direct and Inverse Variation. And honestly, this whole chapter is going to be about rational functions, which kind of go in line with the inverse variation. But we're going to throw the direct variation in there just so you can see the differences. So let's just begin. All right, so first of all, let's just talk about what it is. And they're nothing more than formulas that are used to describe relationships. They do have particular templates, some similarities and some stark differences. So I'm going to put them side by side so you can see what the similarities are and what the differences are. All right, so with direct variation, it's a set of inputs and outputs with a constant ratio called K. Ratio meaning a fraction or a division problem. It is a linear function, and it always passes through the origin. It is also the slope of the line. So this kind of is an Algebra 1 concept with the whole slopes of lines and graphing lines and so forth. In particular, I want to point out the fact that this does go through the origin. And if you recall, y equals mx plus b. M is the slope, and there won't be a y-intercept present. It'll be understood to be 0. All right, and in like manner, an inverse variation is also a set of inputs and outputs with a constant product called K. So there's where the difference is. This one over here is a ratio, and this one here is product. So what I like to do is say direct, divide, direct, divide. So that's talking about the constant ratio. It is a rational function, and it has horizontal and vertical asymptotes at y equals and x equals 0, which is the x and the y-axis. So in essence, it tries to avoid 0, 0 with those asymptotes. Okay, so the equation for direct variation looks like a line. Y equals kx. It looks very similar to y equals mx, and that's because k and x are kind of representing the same thing. Now, if I were to solve for this value of k, I would divide both sides by x. And so k, again, is the ratio or the division problem of y over x. And if you recall, slope is change in y over change in x. So that ought to help you remember which variable goes on the top. The equation for inverse variation starts out as a ratio, but when we solve for k, we're going to multiply both sides by x, we get the product. So that's what all the product and the ratio actually is referring to, the k values. Product is a constant ratio, and the constant of variation, and this is the ratio. Okay, so let's take a look at direct variation. And here are 4 different types of questions. We're going to try to find the value of k. And remember, to find the value of k, direct divide, we're going to put the y over the x. So in the first example, it's going to be 4 over 1 because the ordered pair, 4 over 1. In the next one, we get 8 over 2, 12 over 3, 16 over 4. And all of these are constant because when you reduce these they all equal the same number. And that's why it's called a constant. We label that constant with the variable k just for sake of consistency. Number 2 is done the same way. Let me back up. So what I'm going to do with that number 4 is I'm actually going to replace it back into the template for the direct variation, y equals kx. I'm going to take out k and put in the 4. So that's the second part of this question, is saying write the equation. Okay, so on to number 2. I'm going to run through these real quick. Put y over x each time, and you get 1/2. Now let me talk about that 0, 0. Because this graph goes through the origin, we don't necessarily need to include this one. It's just kind of a reminder that it does go through 0, 0. So the constant that we see throughout all these ratios is negative 1/2, which is the slope of the line as well. Numbers 3 and 4, we're just using a different platform. We're putting it in a table form, and we're still going to put y over x, and each and every time they reduce down to the same constant, 2/3. So it's going to be y equals 2/3 x. And number 4, the same way. Equal -3, so it's y equals -3x. Okay. Now let's take a look at inverse, because this is a little bit different. To find the value of k, you're going to multiply the two instead of divide. So when you multiply, you get 24 each and every time. But the equation for inverse variation is y equals k over x. So we're going to take that 24 and put it in place of the k value, because that's what we just found. In like manner, x times y each and every time, if you go through the process of multiplying all these ordered pairs together, you're going to get 36. So the equation is y equals 36 over x. Okay, in the next one, we get 12, so it's y equals 12 over x. In the next one, we get 48, so it's y equals 48 over x. All right, let's move on to the next set. So basically what we see with direct variation is as x increases, y increases. So think of a line. As you go down the x-axis, the y value gets higher and higher. Or as you go to the left or to the negative values, as y decreases, or excuse me, as x decreases, so does y. So they do the same thing. But with inverse variation, as x increases, y decreases. Or vice versa, as x decreases, y increases. So it's got that opposite effect going on. All right, here are some real-world examples. And remember, this direct variation was the more touchdowns that are made, the higher the score is. One increases, the other increases. The inverse variation is the less sleep you get, the more tired you will be. So there's that opposite connection. All right, direct variation examples, as we've already kind of done. Y equals k times x. Okay, it looks like an equation of a line here. And over here, same thing. Okay, so we just kind of went through that a second ago. Here are some non-examples. The disqualifier for this one is this +5. We can't have it. And the -18 in like manner. The disqualifier here, if you take a look at it, just look at it real close. What do you see? So x is supposed to be in the denominator. So that's what disqualifies these two. All right, when you graph both of these, they're going to be a little bit different. As I mentioned before, the direct variation is just a straight line. And inverse variation has two branches, okay? Notice the x and the y-axis are asymptotes, so there's a branch on the left and there's a branch on the right. They are in diagonal corners, so you can have it in the first and the third, or you can have it the second and the fourth quadrants. Now let me back up and say that over here, this is your line that goes through the origin, and it's positive slope. In like manner, the line that goes through the origin has a negative slope. Okay, some non-graph examples. This one is disqualified because it doesn't go through the origin. And this one is disqualified because the x and the y-axes are not the asymptotes. Remember, with inverse variation, we're trying to avoid crossing over the x and the y-axes. Okay, so in this last, I think this is the last one. No, it's second to last. Identifying graphs. It says identify the graph that represents a direct variation. Okay, and this one is yes, because it goes through the origin. And the slope of that line, if you count the rise over the run, is going to be 3/2. The next one is no, disqualified because it doesn't go through the origin. The next one is yes, because it does go through the origin and it is a straight line. The slope of that line is -1/4. And last but not least, that's yes. The slope of that line is 3/3, which is equal to 1. All right, so here are some examples that you will see as you go through some problems, y varies directly as x. So here's the key word. You might want to highlight that in your notes because that gives you the template that we're working for. To get the value of k, remember d divide. We're going to divide y by x. So we're going to get 27 divided by 9, which is 3. So the the variation function is y equals 3x. And the next one, the only difference here is that we're not using x and y. We're using b and c. So I want you to notice the order will matter. You need to be able to figure out which one is the y value because my value of k completely changes if I switch these. So notice that in this template, y is the first variable mentioned. So b is going to map itself to the y variable. So our equation will be b equals k times c. All right, and then to find the value of k, d divide, you're going to divide y by x, in this case b by c, and you will get 8/3. So your final equation is b equals 8/3 c. All right, so I'll stop this video here and pick up with a few more examples in a later video. Hope it was helpful, and let me know if I can do anything to help you.